I have the name Fossati, who is an engineer in the Linux kernel working group at Linaro. He has previously worked in ARM, and he's a key contributor to the IEEE Racks group. And I think it's very much right to say that he's a grandfather of legislation. He has a lot of knowledge, and some of which he will be sharing with us in the slot. So please go ahead.
Thanks very much. So I went to my colleagues at Linaro and asked them what would be a good target for formal verification. What is a project that they're working on that would benefit from some input from the formal verification point of view. And here's a collection of use cases that I gathered from them. So I don't take credit for everything, but two of these things that I'm going to present. In order to sort of make sense of what the use cases were, maybe mainly for myself, but also for presenting in a sort of clear way, I try to create this format where the use case as a name and as a context in which it lives, and as a more precise description, as a set of goals, and as maybe, if you're lucky, some specification on where to start and model your verification. So all use cases, but one I think have gone through this sort of workflow. The one that doesn't is one which is a meta use case, or which is used one. I'm curious to see what your reaction is to that. And I also created a couple of buckets. One is emerging protocols, and the other one is running code. And because I work from Linaro, this is running code that especially targeted to architecture. So starting with emerging protocol, the first use case I have is the suit manifest processor. So suit is an effort that the IATF has been dealing with since I think 2015. I'm still correcting if I'm wrong, but it should be 7-8 years. Suit is the name of the working group in the ATF, software update for Internet of Things, so updating small devices is the primary target of this working group, and creating specifications that target this use case. And if you zoom out a bit, this thing goes as one of the tutelants of the PSA certified from the API. An API that deals with internal communication components in the device for organizing an update. Confusingly, suit is also the name of the protocol, which describes a manifest, which describes the installation process. Now, this is not the usual manifest. The declarative kind of things is sort of declarative imperative in the sense that there are instructions within the manifest payload that are called common sequences that, in fact, are instructions for the recipients of the target application that orchestrates the update on the device on what to do with the installed payloads. And these common sequences have semantics, and they're fetched from the manifest, decoded, and executed by the so-called suit manifest processor. So this is the picture, the ASCII picture is SVG. The white dot is the target of potential formal verification. So it's the interpreter of the suit manifest. Yeah, what is the goal here? The goal is that you must do this update in a secure way. Sue does a very good job in describing what the threat model is and what the requirements are to address the threats that are identified by the threat model. So in this case, you're going to have the spec that describes what the manifest is supposed to do, which is a spec in ISG processing, I think, at this point in time. So it's very, very late stage in the IATF process. So it's basically waiting for, I think, a couple of these subs to clear to then be promoted to RFC status. So there is not much room for working on the protocol itself and trying to influence the protocol itself through the formal verification stuff, but better late than never. No one has attempted a formal verification protocol as far as I remember. So that would be the thing. And RFC 9124 is the threat model and requirements document, which is the thing that describes exactly what you want to have from this interpreter. And therefore, I think this is a very good candidate. Number one. Number two, core interface. The context is the RAS verifier. So I hope you want to know what the RAS verifier is, but if you don't, it's yeah, here you are in the picture. Is that black box at the middle? And the Corim is the sort of manifest again to describe endorsements and ref values to the verifier. And it is a here compared to suit, you have a lot of leverage because it's 04, the version, so very early in the process. If you join the effort, you're gonna be able to influence that. I think massively. Yeah. So what is the goal? What is the context here? So you have you verify you have input evidence, and this which is the attestation coming from the tester, and then you have the endorsement of values that are provided by the supply chain, sometimes supply chain. These two conceptual messages, they describe reference states and actual states of the thing. And what the verifier does in the early stage is to compute what's called ACS, which is an accepted claim set. It's basically a combination of all the reference state and actual state that can be achieved in the tester. Then the second phase of verification of appraisal is you take this ACS and you actually run it through your policy engine. You apply your appraisal policy for evidence and come up with an attestation results. So this is the anatomy of the verifier, very high level. The white dot is where I think there's a room for applying some form of application, because the ACS evaluation needs to be deterministic, and needs to be deterministic because you want that because the verifier needs to be neutral, right? So every verifier must be able to compute the same ACS given the same evidence and otherwise you give much leverage to a verifier, right? So there's an option for enforcing, for centralizing, right? So for giving more power to that box. We don't want that. We want this to be completely deterministic, and therefore, being sure that the protocol is such that you cannot get to two different outcomes given the input is a fundamental property that needs to be verified. Yeah, so this is the goal, the implementation of VCS. The specification is here. As I said, it's very early, it's 04. We have weekly meetings that you can join if you want. This document is not in excellent shape, I would say, but we are welcoming any input. So this concludes, I think, the protocol stuff. Now I have other use cases come from well, the running code land. Right, so this one is the main use case that I was mentioning before. The use of runtime verification, I don't know how many of you have heard of it. No, great. So as you know, Linux can be if there's a set of patches that you can apply to a normal vanilla to make the time, and this enables a lot of use cases that are on the safety critical end of the spectrum. So with self-driving cars, electric medical devices or not. This runtime verification framework that exists in the kernel since 6.0 is sort of a feature that was introduced exactly to look at these real-time use cases and make sure that the behavior of the task synchronization, which is critical, right? Because of the latencies is such that you can actually executively measure the space, right? And in the worst case, the code base is sort of layered on top of the theoretical work that has been done by Daniel, who's now in thread, I think, because this is, if you want to look at it, it's very interesting. And the idea is that you create a model as a set of formal specs that are based on automated theory. So basically you create the state machine of the thing that is under verification, and although the state machine for the Linux kernel or the subsystem of the Linux kernel is incredibly complex, the key insights here are that you can build that super complex model, say the state machine with I've been speaking about thousands of states and thousands of transitions. These things, your bonus things can be built from a very small set of simple state machines and rules for organizing, for composing these state machines. So, and the other insight that is in the cases that I mentioned before is that surprisingly, when you plug this into the running kernel, the overhead that you get is acceptable. So even more surprisingly, it is better to have this as a synchronous system, right? So the stream is processed synchronously rather than stashing it in post-processing. So the tax that you pay are very low because you can implement the state machine as a big matrix and 8 kilobytes of space, you have all this very efficiently done. And the interesting thing here is that validation of the model composes two things. Right? One is a traditional resource made with analysis that through the properties of the data that you have built. But then you have all this instrumentation that is compiled into the kernel module, flexibility to the module, that basically consumes the streams of events coming from the subsystem, for example, 135, and matches it again the state machine that you have built. And on the bottom of that, yeah, maybe this is easier. On the bottom of that, you have so-called reactors, which are basically actions that you can associate with specific events. You can ask to raise the output, you can ask to bind, so you can have safe modes in case you safety critical and you don't want to do something wrong with the life of someone. Or you can even do your custom things. So a very flexible model, and one that is, as I said, because I couldn't come up with anything specific yet, but I'm sure that we're going to have many situations in which this framework could be applied in useful ways. So if someone has an interest in taking a look at the formal aspects, and we can help building the rest and coming together with a complete solution for specific use cases. Right. Another one was bootstrapping of platforms, in particular microcontrollers, so IoT stuff, very small stuff, and MCU boot is the thing that we use. It is a very neat piece of software that is OS and hardware independent, so it can run on multiple different operating systems. So if you can embed OS, Files, Minute, and attacks, I think. The top and also it has a hardware abstraction area, which makes it independent. Of course, it runs man, but it's running Linux, I think, and RISC-V as well. This piece of software deals with software upgrades, so it's thing for dealing with the suit kind of things. And the interesting bit here is that it's under certification at the moment, under the PSA certified scheme. And yesterday someone mentioned the idea of having, say, formal verification in one of the case for Q&A, right? And I think this is an excellent candidate. I'm not sure whether the timing is right, but as I said before, for the suite use case, better late than never. What we have at the moment is a tool called SIM that is a handwritten runtime verification thing that synthesizes basically inputs and workers that to check whether the functioning features of the program are okay. One thing is that it only covers the functional features. We don't have any coverage for the crypto stuff, which for security is very relevant. But apart from this runtime verification tool, which is partial but useful, but not exhaustive, there's no formal verification that has been attempted on. We think that a good thing to have that. And one of the aspects here to cover, which is not necessarily a security aspect, but more functional thing, is the fact that the software behaves correctly in case of power loss, so that you don't break the device if you have a power cut in an update sequence. So this would be one of the main goals here, which is not security. So I don't know if they're interested in these kind of things, but still useful. We have specification for this. We have an overall architecture document that explains what the thing does. We have code and other documentation for explaining what the behavior is to different images. So it might be this angle, which is security angle to analyze as well. So this is some code. Third and last use case that I have here is in the context of the Android virtualization framework, so AVF, which is basically a way to create secure graphic execution environment for application code on the Android devices. And this is a kind of feature that can be used to cover situations where the usual sandboxing that Android is not sufficient. You have just discussing workers and stuff like that. So this is built on top of, so the key building block here is the advisor, EVM, advisor, which manages these isolated primitives for the PVMs. You can imagine as VMs with the primary so and what is happening at the moment is that in one world you have no architecture, but you have the secure world, it's basically the execution is partition into secure world and normal world. And on devices and Android devices, secure world runs a bunch of trusted applications which deal with security-related processing, like crypto, like payments, like DRM, and things. With this new implemented in place, with PVMs, the trend is to move away from so-called TAs into and bring that logic into PVMs. And this is motivated by you have from the developer perspective, much richer environments, and from a population point of view, kind of update things here. Because updating TAs is a pain in So the trick here is that unfortunately, complete TCP migration from TAs to PVMs is not always feasible. And so you end up in a situation, a split situation, where part of the processing is done in the TA, minimum amount of processing is done in the TA, and then the rest of the processing is done in the PVMs. And therefore you have, to join the two and conduct to actually let data go through and be shared across these two processing things. And so the problem now is that this conduit here, which is to boxes, is sort of a multi-hop proxy conduit that it is critical to ensure that no one is missing about the data that is flowing through that channel. And because this goes through multiple execution levels and multiple subsystems, is quite interesting. It's quite interesting users making sure that the thing can be considered a secure channel. Specification here, you have the Android platform security model, which is talking a bit about this stuff. You also have subsection of website that deals with the security and introduces all this concept. this is the last one. And then we take my colleague David, Inges, Joachim, and Vassan. Give me ideas on
While others are thinking, maybe I start with my question. So, maybe I got the numbering wrong. So Soot and Corin were connected, right? Or
No,
you
no.
consider that as one problem or the two separate?
They are
Okay,
separate,
they are two separate.
yes.
And then second, so third problem was Linux runtime verification.
Yes.
And then fourth was Android virtualization framework, right? So you
No,
have four
fourth-
different.
Fifth was AVF. The fourth was MC Boot.
Bootstrapping. Okay, so we have five problems. Okay, so the Corin thing, and I was wondering if there is like there was some discussion on RADs also about the on clauses, and is there already some work towards the formalization? Do you know, or is it still under very, let's say, what is the current state of formalization? Can you say a few words about that?
Yes. So we're ironing out the design. There is one crucial aspect that has not been settled yet about the amount of matching context that you have when using and how you deal with the construction of the matching context. So there are two schools of thought there. One is you need to minimize that and make it static and then have a depending on the thing that basically adds claims to be accepted themselves. But you always mesh against the same exact thing that you have. If you start with that, you don't touch them. The other school of thought is which supports more subtle use cases, but is also more dedicated to deal with. And I think that's a usability problem. Who needs to compile the manifests and be sure that what is compiled is what actually gets executed by the machine. Since the matching context should be an experience that can be fed by the process of matching. You imagine is the thing, okay, you answer the claim set, then that thing that you have to the user becomes part of the matching context of the next situation. And this creates some sort of two problems. Usability complexity as well. Which doesn't play well with the situation where you have a embedded verified function. You want to minimize instances of both sides. That's what's about complexity. So this topic is not yet. I don't want to say. I think someone that comes in with power verification mindset could somewhat challenge I would say authoritative way by providing more needs that can use the decision process here, which is not yet finalized. So once we have that, then we have the whole machine listed and start learning. If you have all of the RATs working group section of the master ETF, you see the end presenting the material operation, which is exactly this. Those features are in of what's what we see from the other side.
I still have some question about that, but that is, but any other, yes, please.
Question to question especially to the productivity period presented in the end. So what I read is that the main reason for Android to introduce productivity in the end source which migrate away from this trusted ethics in the T is was that also security concerns that the isolation of trusted applications in the trusted execution I never matured to a level where there would be strong isolation where you would put like different vendors put in their cluster applications, and they would be strongly isolated from each other. Is that something you would agree on, or because you just mentioned two reasons for the PKVM, which was I think more functional?
Maybe, but Anas, please.
I wouldn't agree. Because like the figure, what it doesn't show is the, so like in this picture you have, for example, the trusted OS, which may be OpD and the trusted application sitting on top of them. And there you could argue that maybe the isolation between these trusted applications is not that great because it corresponds to what you have otherwise on the normal world with applications and kernel. However, with the introduction of the secure world hypervisor, you have like obviously the change in terminology, this partition manager, but then you essentially have something that is equivalent to a hypervisor on the secure world with strong isolation on the data sub. So in that sense, I don't think the isolation was really a problem there. Of course, the isolation always brings a lot of extra code. Like as soon as you isolate, you have to replicate code, which is a challenge. So like in the end, you have every layer of isolation and then a duplication of a secure and non-secure, and then there's typically another process sitting on the side as well for the secure element. For example, you have a lot of code running on the device, the very complicated code chain in the end. This model with the PVM, I don't think it will make it that much better, but I think this is an unsolved problem in our field on how do we get this provide proper isolation and at the same time avoid creating this tremendous complexities in the software set.
Maybe I can go in your direction in the sense that there's no intrinsic problem with that, but there's a sort of derived problem from the fact that it is such a difficult operating environment to deal with. So upgrade is a terrible thing, right? It's not as easy as just restarting a VM and installing a new engine. It's not. So from that point of view, if you look at security from a bigger distance and you include the fact that you need to deal with the life cycle of the device over a long period of time, yes, I think it's easier to fix problems that happen in that space than here. So there might be a better story from a security perspective, but not necessarily from an isolation perspective. As I said, it's done correctly. It's not a problem with implementation, that is a problem. I think Gada has the hand raised. Yes, Gada, please go ahead.
Yeah, hello, good morning to all of you. Thank you, Thomas, for the presentation. Actually, it's a question a little bit like the previous one. I didn't get the point of having a PVM. Why do we need an almost secure environment running alongside a secure one? So, what's the point? Why do you propose something like that?
Well, for the same reasons, we have, say, architecture like CCD and TDX and ESV, except here you don't have the hardware facility to implement the isolated primitive, and therefore you need to rely on trusted advisor to do that. You need to do all of that in software. Basically, this is targeting Android, so you need to think of ARM-V8 architecture, so things that happen, special extension in faster computing, but you still want that kind of feature, and that's what Google came up with. Software-based isolate.
Okay. And another question, the PVM and the PKVM. So is this, let's say, a paper model, just an idea today, or do you have some implementation of it?
No, this is fully implemented. There's one called in the substream. Yeah.
Okay.
And use this thing that has a hypervisor thing on how so that's station translation of the memory or the partition space and give you isolate and private computing things for these PVMs that can be mutually distrusting. Same way as CCM. And you can provide you at a conceptual level. They're completely different implementations, but from a logical level, they're the same construct.
Okay, and you talked about migrating trusted application to PVM or in the other sense. Did you consider or attestation either before or after the migration and the two sides? So the trusted application attests to the PVM and the PVM, sorry, and the PVM attests to the trusted application. Did you consider this? Do you think that has a sense, has meaning to think about attestation in this context?
There's an attestation story here. It's based on that. I will not mention it, but there is one. It's also I can point to the code in that sense. It's called BCC. Maybe I said something wrong in the presentation, but there's no migration from, it's only one direction. So the trend is to move trusted application logic into the VM world. There's no thing on the other.
Okay. Okay.
The thing is that there's some inertia there because not all of the functionality can be actually migrated. No, this is one direction. And the station. Nice piece.
Thank you.
Cheers.
So one quick follow-up on this. So, I think on this slide or the before you had some double kind of errors, which was also, but now it's clear to me. Okay, you were showing, I think between the PDM and the TA, but I'm interested in understanding that from the verification perspective, the challenge is to verify the security of this channel. Is it correct? So the independent kind of, is there already some specification of the protocol? Does it use some standard protocol or from the verification perspective?
Yeah, what do you need to model is actually which is a multi-hop in transition from attention level in that sense you have a narrow spec that tells you that what happens when you transition, what it does. And you also have the code to use that. So the work that you have to give them stuff that
From protocol perspective, it would be something new to the existing protocols like TLS, SPTLS or something, or completely. So there is no challenge related to the protocol verification.
There's no creep in there. There's another spec that could be useful in places FFA, which describes what we do in terms of building the convicts and that. So, yeah. And that's another aspect. It's fun.
Perfect. I think they are like very interesting problems from the education perspective, and hopefully we discuss it in the last session. Perfect. Any final questions?